We're going to talk about types of bonding, ionic versus covalent. Let's take a look at how atoms connect to one another. We're going to be looking at two types of bonding. The first is called ionic bonding. The nature of ionic bonding depends in part on the elements involved. We're going to look at sodium, for example. Sodium has an electron configuration of neon 3s1. And that means that sodium has one valence electron, one dot. And we're also going to look at chlorine. And chlorine's electron configuration is neon 3s2, 3p5. The organization or arrangement of electrons in sodium's valence shell, 3s2 electrons like that, 3p. There are, of course, 3 atomic orbitals, 5 electrons, 1, 2, 3, 4, and 5. So chlorine gets 3 pairs and 1 unpaired electron. An ionic bond is going to be essentially just a transfer of electrons. Now sodium, we know, wants to be stable. It wants to be isoelectronic, or have the same number of electrons as neon. Neon, if you remember, is 1s2, 2s2, 2p6. That's neon. And neon is stable. It's a noble gas. It's stable because it has 8 valence electrons. Well, the rule that says that that has to be the case is called the Lewis octet rule. So the Lewis octet rule says that all elements want to have 8 valence electrons to be stable, because the noble gases have 8, an octet of electrons. So sodium wants to get rid of its 3s1 electron. It really would like to get rid of that. This lone dot is keeping sodium from being stable. Chlorine, on the other hand, is very, very, very close to having a full valence shell. It has 7 valence electrons. It would very much like to be like argon. Argon is 1s2, 2s2, 2p6, 3s2, 3p6. That is argon. That's the closest noble gas to chlorine. And chlorine would very much like to be it. Chlorine is missing 1 valence electron. So we can show what happens between these two elements if we simply allow sodium's 1 electron, its 3s1 electron, to be transferred over to chlorine. Sodium wants to get rid of 1 so that it will have 8. Chlorine wants to gain 1 so that it will have 8, like argon. And in doing that, in just allowing sodium to transfer 1 over, sodium becomes an ion, but now electronically stable. Chlorine becomes an ion, but also electronically stable with a minus charge. And because these two have opposite charges, they're going to attract each other to make sodium chloride. Sodium chloride, of course, we write as NaCl. Now we can do the same sort of thing with all kinds of different metals and nonmetals. For example, if I want to do calcium and nitrogen. So calcium has 2 valence electrons and they are paired. Now if you don't remember how to do that, you want to get yourself a periodic table, and you want to make sure that you know how to get the number of valence electrons by looking at where the element is. If you have the periodic table numbered with these Roman numerals, the valence electrons are very easy. Group 1 has 1, Group 2A has 2, Group 3A has 3, Group 4A has 4, and so on and so forth. The only thing is that this is labeled as Group 0. It's often labeled as Group 8A, and because they have 8, of course, except for helium. So calcium is in Group 2. It has 2. It is 4s2 is its valence shell. It's right after argon, 4s2, so it has 2, and they are paired, which is why I have a pair of dots here. Nitrogen has 5 valence electrons. They are arranged as a pair and 3 unpaired electrons. Again, nitrogen has 5, it's 2s2, 2p3, and the 3 electrons in the 2p sublevel have to be separate in separate orbitals because of Hund's rule. So we can show how calcium and nitrogen will bond? Well, calcium is wanting to get rid of these 2 electrons, so it can give 1 and 2 to nitrogen. And when it does that, it becomes stable. It becomes charged, yes, but stable. Its dots are now gone. Okay? So there you go. But this nitrogen is not yet stable. The nitrogen just gained 2 electrons, but it needs 1 more. It needs 1 more electron to be stable. Well, that means I'm going to need another calcium with its 2 valence electrons. And that calcium can give 1 of its valence electrons to this nitrogen just like that. And when it does that, nitrogen now is stable. Nitrogen has now 8 valence electrons, just like its nearest noble gas. It gained 3, so it has a -3 charge, but it's now stable. But this calcium still has 1 more electron that it needs to get rid of. So that means I need another nitrogen. I'm going to put in another nitrogen with its 5 valence electrons, and the calcium will give its 2nd electron to the nitrogen. And when it does that, the calcium now becomes a calcium ion, stable with a charge. But this nitrogen needs 2 more to become stable. It's not stable yet. So that means I need a 3rd calcium atom with its 2 valence electrons, because this calcium is going to want to give its electrons 1 and 2 to nitrogen. And when it does that, the calcium atom becomes a calcium ion. It is now stable, but with a charge. And the nitrogen now has gained its 3 that it was looking for, and it becomes stable with its 8 dots and its -3 charge. So now everybody's happy, everybody's stable. I have 3 calciums, and I have 2 nitrogens. And so the formula that I will write is Ca3N2. 3 calcium ions, 2 nitrogen ions. The metal is always written first. This is called calcium nitride.